Hmm. Okay, everyone. We'll just give like around two to 3 minutes, and then we start the live stream just in a few. Yeah. Okay, I think we're going to start. GM, guys, how is everyone? How was last week? I hope last week was a great session. If this is your first time joining in, welcome to the second week of the Celo Bootcamp Series, which will be holding for 4 weeks. This is the second week. So, GM, everyone, it's so nice to meet you. As usual, my name is Cindy Kamau. I'm the Developer Relations Lead for Celo Africa DAO, and I'm going to hand it to my teammate to introduce himself again. Jordan, yes, before we continue.
GM, GM everyone. My name is Jordan Muthemba. I'm a smart contract developer, and yeah.
Okay, so we'll just start with a quick recap of what we learned last week. So we started, first of all, with we were learning just a quick introduction to blockchain. We went through several blockchain concepts, like what is a blockchain in general, what are nodes, what is a peer-to-peer system, and essentially everything that, and also a gentle introduction to the Celo ecosystem. So for this week we'll start with an introduction to Solidity. So we'll be doing a simple smart contract. So and then after that, my colleague Jordan will get you guys through an ERC 721, which is an NFT smart contract, which you'll be using, which will give you the foundation of the assignment, which you're going to be building for next week as we build up to week 3. So with that, just give me a second. So the format of how we're going to learn in this today's session is it's going to be fully hands-on. So we don't have slides, so we'll just be coding like a smart contract from scratch, as I will be talking about Solidity concepts. And then from then on, in our dedicated group, I will send all the materials which are needed. So if you haven't joined the Telegram group, as we continue with the session, we'll be sharing the Telegram channel, right? So the first order of business is just to set up, we'll just be coding entirely from the browser. So there's not really any development setup, which you'll be doing on your local machine. So we'll be using a tool called Remix IDE. So just a second, let me share my screen and then I'll take you guys through whatever we'll be building. Okay.
Cindy, I think you're on mute.
OMG, sorry, I was on mute. So like I was saying, sorry guys. So I was saying the first order of business is you just in your browser, whether it is Brave, Chrome or Safari, you'll just come and search Remix IDE. So just to do that again. So Remix IDE. Yeah. So we'll be using this. So Remix IDE is an online developer environment which helps you to write simple smart contracts and also helps you to deploy them and also interact with your smart contract. So I hope everyone is here. Let me just do that. So to give you guys a quick overview of how the interface looks like. So here we have the homepage, which is just to show you what Remix has and all of these things. And then in here, this is where we'll be like writing our smart contract. When you come and check on the left side of it, before we get to like the toolbar over here, we have several folders, right? We have depths for dependencies, we have states, we have artifacts, and then let me just quickly delete this. Okay, so normally in completely new directory, you'll have another directory called contracts, right? And then it has sample contracts over there. The reason why I don't have it on my end is because I've been using Remix a lot to do some sample smart contracts. That's why I had deleted it. So, and then over here to the very far left of it, we have like the homepage. We have the file explorer where you're going to see the files. The search is when you like trying to do a search. Let's say you're searching for something in your smart contract, you just come here to the search bar. Now here it shows you the Solidity compiler. So the Solidity compiler, what it does is the way when you write like a sample Solidity smart contract, it is in the language which you understand. It is in human readable format, right? So for the machine, or rather the EVM, which is the Ethereum virtual machine, to be able to understand whatever you've written and to execute essentially your smart contract, it needs to be compiled to machine code. And by machine code, normally in technical terms, we call it bytecode. So if you see the term bytecode, B-Y-T-E, bytecode a lot, so it's just the machine code, right? And normally it's just a binary system. So you'll find when you go and check it, you'll find it's like a ones and zeros and all these things, right? So the compiler, that's its work. So it compiles whatever you write in like Solidity into machine code. So in here, you can see the compiler version which we are using is 0.8.26. What we mean by 0.8.26, this is a version of Solidity, right? So you can go and read up more on semantic versioning because this is semantic versioning. So this is like a major update, minor update, and then a patch. So we call it that way, right? So when the guys who are maintaining the compiler, when they release a new version, you will, like example, we have 0.8.27, 0.8.28. The reason why it's coming to 0.8.26, it's because you'll realize it's like this is the the most stable version of the compiler, right? So this one will come to you'll come to understand what it's important when we start writing the smart contract from scratch. Now here, this is where we'll be deploying our smart contract. For this session, when we're building our simple smart contract, we're going to deploy it in a virtual machine. So essentially, when you see the environment is Remix VM Cancun, what that means is essentially you're just it's a virtual machine. It's a simulated, yes, that's the term. It's a simulated environment. So it's not like, example, if you're deploying to like a real testnet, which will come to that later on. So this is just a simulated environment that Remix has set up. So to help you deploy your smart contract really quickly for testing purposes and also to interact with the smart contract, right? So when you see like the Cancun, the main network, these are just an environments, okay? This is the account which when you set up like when it set up the development environment for you, this is the account which you'll be using to like pay for gas fees and all. And so we're going to talk about gas fees in a few. So like you can see the gas limits, estimated gas, and then the value of the gas. When you see way, that is the currency which is used in gas fees. Kind of like in Ethereum, the currency of Ethereum is Ether, but in when it comes to gas, we pay it in, we name it in units, called the way. So 1 ether is almost to, I think, around 1 quintillion ether, or way or something. Sorry. So when we now deploy the smart contract, which we'll be building slowly, we'll come and see it at this section, deployed contracts, right? So this is for when you want to start debugging. This they've also, if you want to like initialize like a GitHub repository, let's say the smart contract you're building, you want to eventually push it to GitHub, you'll come here. And these are other, if you want to do other custom configurations, you'll just come here, right? So with that, let's come here. So the first order of business is, for us to avoid a lot of clutter, we're just going to delete everything from here and then we start from scratch, right? So okay, so the first, I hope everyone is like following through with me step by step. So we're just going to delete everything. Okay, so this is it, right? So I hope everyone has like deleted everything in our workspace. So just a bit of home to do some bit of just a set of house rules in case you have any questions, because this is a live stream. So if you're streaming from YouTube or you're streaming from the StreamYard link or even from Twitter, you can come and you can ask questions in the public chat, which it is there. So Jordan and I will be answering them when we see the questions. So as I continue, if you have any questions, just ask it on the search bar, or rather on the YouTube chat, and then Jordan will tell me to like pause, and then I answer the question, right? So with that, let's continue. In case you have any issues, like maybe my screen is not being seen, just say, and then Jordan will be able to tell me, right? So with that, let's continue, okay? So the first step is, let's create a new file. Yes. So this file, we're going to call it a local directory. I'm going to tell you a bit why we're calling it local directory. Local directory.so. So when you put the .sol here, the compiler is like able to figure out, okay, this is a Solidity file. So it will open it up as a Solidity file, right? So with that, I'll just give you guys a quick overview of what we're building. So I will be building in step by step, and I use this approach because sometimes it's good to learn how, if you're presented a problem as a programmer, it's good to learn how you think through the problem and then how you approach coding, right? Apart from just starting with code. That's why I didn't want us to go through the Solidity by example. We'll be sort of going through back and forth in case someone doesn't understand a concept. But the main goal here is to understand the process of essentially building a smart contract from scratch, right? So let's say you've been approached by someone who wants to create a local directory for their area, right? So what features does this person want? So essentially what they want is they want to design a smart contract where, let's say if you're living in example Westlands in Nairobi, so we want to tally how many people live in a certain area in Westlands, right? So what exactly do we need? So first of all, we will need a list of people, or rather a list of residents, sorry, residing in the area. What else do we need? How will we get this list of residents? We'll need to find a way which someone adds the details, right? So as a resident, what do we want? What details do we want these people to have? So the details we want is name, obviously, and then we want the age, and then also, because we want to update the records, if they're still living in the area or not, we want to know, do they still live in the area? Oh, right? So the reason why we are going through this logic slowly by slowly is so that before even starting to write the smart contracts, we have analyzed all the things which we need to add in the smart contract, right? So this is, we want details. So we'll need to find a way of someone adding their details, right? And then also we want a list, right? So we will need a list of all the, we will need a list of all the residents. Again,
Cindy,
if
could you check if you're on mute? Someone is saying you're on mute.
no, I'm not on mute.
Oh, okay. Yeah, you're
Yeah,
good. I think
so Emmanuel, I'm not on mute,
forward.
unfortunately. Sorry?
Telling him to fast forward. You can continue.
Okay. Okay. So let me just add this just in case someone is not seeing what I'm writing. So I think we can, yeah, we can do that first. So we need a list of all the residents who are residing in the area, right? And also, since we're building on a blockchain, we need a way to log. If someone is added, if we add a resident, dent, we want the blockchain. Okay, we want the blockchain, like we want to have like a log of all the events which are happening, right? So if we add a resident, we want like our blockchain system to like log that someone new has been added, right? Also, let me see, what have I missed? So we have the list of residents, we have the details, someone adding their details, and then we want to check if in our list a resident is still residing in Nairobi or not, right? So we want to check if someone is still residing in Nairobi or not, right? And finally, we want a count.
Could you zoom? Could you zoom?
Okay.
Yeah, I think there is
okay.
Yeah.
Yeah. There. Okay. So it's okay, right? Can people see?
Yeah. That is okay.
Okay. So finally, we want to have a count. Like we want to get the total. Sorry. Number of residents still residing in the area. So this will be like the foundation of our smart contract, right? So we will have a local directory, we will have a list of residents, someone can input their details and whether they still live in the area or not, and the age. And then when someone adds a detail, we will find like a logging system. You're going to see it again in something we call events. So once, if anyone adds in their details in our register, in our registry here rather, so the system is going to emit a log saying, okay, at this and this time, we had a new person who's been added, right? So it's a sort of a logging system. And then we want to check if people who are in our directory, if they're still living in Nairobi or not. And then we're going to get a number of residents still residing in the area, right? So that's the basis of a smart contract, okay? So once we do that, the reason why we do this is we're going to talk through the design structures of the smart contract, because normally when you are writing most importantly, when you're writing something from scratch, it's very good to like get the design flow going before even writing the code, right? Example, if we check the details here, name, age, and live in the area or not, this is structured, this is like related data, right? So this data, it's all related to someone. So if I look up a person, I need essentially to get the details of their name, age, and if they still live in the area or not, right? So when you're working with related data, we introduce a concept, or rather a data structure we call structs. But you're going to see it later on. So once you know this is related data, you know the type of data structure which you're going to use to hold this data, right? That's why you're seeing us talking through it before getting to the code. So this will be related data, right? So if they live in the area or not. So you can approach this in two ways. You can put a Boolean. What do I mean by a Boolean? This is something you're also going to see. Do they live in the area or do they not? So it can come into be like a true, false statement, right? So that's a one way you can approach it. So if you're writing the details of someone, when you're putting like the related data, inside there you can say, they can put true or false if they still live in the area or not, right? So when it comes to coding, this is something we call a Boolean, or rather a bool. Okay, so that is one approach. Another approach is we need them to choose. What if we don't want them to say maybe true or false? But what if we want to say live area? Okay, we'll say I will say lives here. Okay, sorry, lives here or moved away, right? So if we have this way, what if I don't want to put true and false? This is now another feature which we call, which is very common, or rather a structure which is very common in programming languages, which we call an enum, right? So there are now two ways which you can, based on the type of, maybe based on your preference or the system design that you want for your smart contract, you will have those two, right? So you get to see why we are doing this. Okay, so we will have for someone to add their details. If you were in the last class, we said if someone is changing the state of the blockchain, that means it is a transaction, right? So if someone is adding their details, essentially we are changing the state of the blockchain. And why do we mean that we're changing the state of a blockchain? It just means in our previous register, that was the previous state, right? If someone adds the new details, we're now coming to a new state with the new person who's added it, right? So this means this is a transaction. Okay, so in order to execute this, we will now need a function. So this is where something we call functions. So functions, they are coming in to help execute. So they sort of execute the code which you need so that you can update the state, right? So that we will need a function. So most of these things we will need a function, right? Now remember, if someone is adding their details, this means this will be a write. We will be writing to the blockchain, right? If we want a list of all residents residing in the area, we're not changing anything. So essentially, we will just be reading in the blockchain, right? So with that, I think we can start. Okay. So once you've started what you've broken down the problem which you're trying to solve in a list of small steps, we're going to start. The next step is now starting, right? That's why it's super important before even you come down to code, you just take some time, you digest the problem which you're trying to solve, or rather what you're trying to build. You sort of create a mental model of all the steps which you're going to need, all the features, and you sort of check all the possibilities which you're going to use in the program, right? And then you now sit down and start coding it. So, by the way, I forgot to ask to mention, for anyone who doesn't know, when you see me put two backslashes over here, this is a comment. So a comment, mostly you're writing comments to give out more information. Yes, mostly it helps out the person who's going to be reading your code. So the compiler on backend it's not going to convert this into bytecode, which is machine code. So this is just for more details, right? So if you see someone starting with two backslashes over there, if you're reading code and then you see two backslashes, you just know it's a comment, right? Yeah, I forgot to mention that. So the first step is, first of all, we're going to put the license of our smart contract. Okay, so why do we put licensing? It's because normally with licensing, you like, it's because of the legal terms, right? So you just want to give out more information about how people can use your smart contract. Example, if you put like a GPL 3.0, if I'm not wrong, I think it means open source. And also if you put unlicensed, that just means if anyone interacts with your smart contract, because what we do know is once you deploy a smart contract on the blockchain, it's going to be visible to everyone, right? And because of legal systems, maybe you're building something and you don't want someone to like sort of copy paste it and then they go and build another product with it, and then it will have so many legal issues. So it's generally very advisable to start with a sort of licensing which you want for your smart contract, right? So how we do that is we write something called XPDX license identifier MIT. So this is similar to if you've ever gone through like a GitHub repository, and when you're like creating a new repository and then you go to licensing and then you see MIT, GPL 3.0 and other things over there, it's still the same licensing system as what you normally see when you're like putting out your code in GitHub, right? So it's still the same. Now, once we do that, remember what we were talking about compilers, right? And there are very many, where's the compiler? There are very many versions, right? So the next step is you normally have to, what is this? Okay. Yes. You normally have to like sort of specify the type of compiler which you want to run your smart contract, right? So how do we do that? We say pragma Solidity. On my end, I'm just going to check the current compiler being used here. So it's 0.8.26, right? So 0.8.26, like that. So there are several ways. Example, if I wanted to specify because when you're deploying a smart contract, sometimes let's say you've already deployed it and then a new version of a compiler is like coming up. And since you had explicitly specified the type of compiler you want, all of a sudden your contract is now not being compilable, right? So normally what you do is you put this on top to sort of give specifications that the range of the version of this compiler that I want is 0.8.26 and any more which are newer, if 0.8.27, 0.28, 0.29. So if we do this, essentially, it's kind of like saying I want 0.8.26. If you release 0.27, if you release 0.28, it's still the same, right? So, okay. So that's one way. Also, yeah, so that's one way of doing it, right? So, and I'm just going to like explicitly say I want 0.8.26, right? But it's advisable to just put just for safety purposes, to just put this I've forgotten the name of the right? So with that, I think we can start. So if you try to, already you can see like if you try to like, let's say we try to like compile this, sorry, invalid SPDX, invalid SPDX license identifier. What have I done wrong? I think I've done everything right. Invalid SPDX license identifier. Just a second. I don't think I've done anything wrong, but just a second.
I think remove the semicolon.
Oh, right. I had not seen the semicolon. Okay. Thank you. Yes. So let's continue, right? So this is something we call now debugging. So as you continue, as you see, there was like was getting errors. So normally when you're building, obviously you're going to come across a lot of errors. So normally the thing you just do is you'll be getting like it's still here because let's try to like compile again. Yeah, so it's gone, right? So the compiler helps you catch several errors, right, as you continue. So what I was trying to do is when we try to compile, essentially there's like nothing here, although it's compilable. So I think we'll now continue. So the next thing is we need to tell the compiler where does our smart contract start. So to do so, we have a keyword in Solidity. A keyword is like the inbuilt functions of the language. So if you go and read like a programming language, you'll always look for words which they've sort of used them to mean several things. So those we mean with that we mean like a keyword. Okay, so a keyword is just to help you just do specific things. Okay, example, if I write a contract, so this is like a keyword which Solidity has given you so that the compiler, when it goes through this, it knows, okay, this is where our smart contract is starting from, right? So just a second. Yeah, I don't. So one more thing, as you can see, there's like a Remix AI Copilot here, so we're just going to turn it off. But if you want, it's just like how GitHub Copilot works. So it just helps you. It sort of suggests the next lines of code based on what you're building, right? So with that, we can continue. So we want our smart contract to be local directory, right? So once we do so, essentially, we've written a smart contract, even if it's empty. So if you were to come here and then you compile to confirm, also another way of compiling is you can just command save. For those of us in Mac, for Windows, you just do control save. Windows and is it Windows and Linux? Yeah, you just do control save. If you're in the Mac, you do command save, right? So if you just do command save, it will sort of automatically compile itself, right? So when you see me not coming here, just know I've done command save. Okay, yeah. So with that, we have actually written a smart contract, although it's empty. So with that, let's continue. Now let's come back to our specifications. So we first of all, we want to map out these details. If we're going to go down to Nairobi and we collect the data, we need some sort of specifications or guidelines of the type of data we are collecting, right? So we're going to start with that. So we're going to like I said, there's something we call abstract. So abstract, it's just a data structure which helps you hold related data. Example, I have a person, I need his name, detail, and I need, I need his name, I need his age, I need where he lives, and whatever. So, and if I want to like look up, if I want to, let's say it's a database, right? If I want to search up, let's say Cindy, I need the details to come forward as name, Cindy, age, this, lives here, whatever there. So how do you put structured or related data? You use something we call a struct. Okay, so with that, we're going to say struct resident or struct person. Let me just use struct person. So the first thing we want is we want the name, right? So if you want a name, we're going to use something we call a string. So a string is like a type. Example, if I was to, let's say, if I have 10 here, I would put a type of uint to 56. So what we do is this 10, when you go check, like, this is now coming towards memory, right? Because this 10, it's going to be stored in memory, right? So this type here, it's sort of telling the compiler, the sort of like, when it comes down to bytes and bits and whatever, the sort of bytes which will be given to the slot for storing the 10. That's why you state here the type of whatever, like you want it. This 10, you're seeing 10 here or as a human path, right? But when it comes to the machine, it's going to be converted into zeros and ones and binaries. So you're just saying, I want like 256 bits of this character 10 to be stored in memory, right? That's why we normally state all these things here. So if you see a string is like now it's quite a complex data structure. So you will see why. So normally a string is normally put in the category of something else, which we call arrays, an array, and what have I forgotten? I think an enum. Yeah, so it's like a complex data structure. Why? Because a string, it's like when you're saying string hello, right? So for you, you've put like a string hello, right? But when it comes to now the backend, a string, it's sort of an array. And by array, I mean like a collection of similar items of bytes, right? So it's a complex data structure, and you'll come to see why. Okay, so normally when you're writing like a name, because it will not make sense to say like, am I like a uint 256 name, because this is not a number, right? So that's why we're putting a string. So let me just delete all this. So we want our name to be a string, right? So we're going to do that. The next thing is we want an age. And because an age is a number, we're going to use the uint, and uint is an unsigned integer. So uint 256. And by unsigned, we mean you can only put positive numbers. So let me just, uint means can only use positive numbers. And by positive, I mean, let's say 1, 2, 3. And something very important, it's positive whole numbers. So it's not like, let's say 3.5, like a decimal. It's just whole numbers, okay? If you wanted to use negative, you now use something we call an int instead of uint, which is a signed integer. So if you wanted to put like a negative, let's say negative 256 or something, or negative 45, you're going to put an int 256, and this is just the number of bytes which you want. So you can put several. They normally start from 8, so you can do 8, 16, 32, 64. Okay, 64, continue like that. So normally it's just advisable, even by default, if you forget to like put the type specification over here, by default it's given there uint 256. Okay, yeah, so let's just continue. So we want our age to be. Now, something here is, remember, we want to say, do they live in the area or not? The first thing we said is we can handle it two ways. We can say it's a Boolean, lives here. Here or not. And by the way, if you check the naming sort of standard which we're using, this is something we call camel case, which is going to be a bit important also. So you start with like a small, a lowercase, and then from the next words which you're putting, you put like an uppercase, right? So this is something, if we wanted to, we could put it a Boolean, right? And if someone is living here or not, when we now interact with our smart contract, which we're going to do after we've finished, we're going to say either true or false, right? But that's not what I want myself, because I love being complicated. So what we're going to do is we're going to introduce something else which we'll call an enum, which you're going to see how they works, right? So residency status, Now, obviously, it's going to throw an error because the compiler does not know. Okay, no, sorry. Oh, this is yeah. Sorry, I was like using for another language. So declaration error, identifier not found or not unique. What that means is the compiler does not know what this residency status is, right? So with that, we're now going to handle this. Okay, so remember, just to add here, this is to show whether you live here or not. Okay, so afterwards, we're going to like give out this smart contract. So you go repeat again, and then you internalize what you're saying, right? But also, in case I'm going too fast, please just say so that I can sort of slow down. And if you've not understood anything, please just hit up on the chat box, and then we can continue, right? So far we are good, although we have this, which we're going to handle next, right? So we have now our structured data. If we go to collect data from a person, we know we want a name, an age, and residency status, right? So the next step is to now handle the residency status, right? We're going to use something we call an enum, which I'm going to talk about right now. So remember, like I was saying, a struct holds data which is related to each other. What if you wanted to hold data which someone only has one choice? Example, let me look for a quick example. Let's just do this here, right? Let's say student, you're a student, right? And then we take like we take your name, and then we take your Okay. We take your age, and then we want to check the class you're in. Okay, you cannot be in two classes at once. So let's say class, right? So with this, how do we include all the options which you have, and then for you, you get to choose one? We use something we call an enum, right? So you'll just come here and you put an enum class, and then you'll be like, okay, maybe you're in class 1, class 2, class 3, class 4, right? So you cannot be in two classes at the same time. But we want to combine all these details because they're related to our class, right? The type of class you're in, but you only have to choose one of each. You only just have to choose one. So instead of now using a struct, because all this data is related, and here you're only choosing one variant, you're now going to use something we call an enum. Okay, so that's what we're also going to do here, because in our residency status, it's either you live here or you don't. You cannot have both. That's why we're using an enum. So when you come here, we're going to say either you live here or you moved away, right? So up to there, let's see, have we correctly, like, do we, okay, and something else. So when you want to like call another data structure, you just call it here as a type. You see, just like how I've called like a string and unsigned integer, if I wanted to now include this enum and nest it inside of my struct, what I'm going to do is I'm going to put it here as if it's a type, so that when the compiler is going through and then it sees residency status, and then it'll be like, oh, okay, so this enum is related to the person. So that's how you sort of nest related data which are different to one struct, right? So this just shows you how struct is a very powerful data structure, which you'll be using it a lot. So that's why I'm intent on, I hope you've understood how a struct works, right? So that's why you've seen I put here residency status. So when you see this variable here, residency status, you'll just know it's related to the enum. Okay, and the enum is this person either lives here or they moved away, right? So let's continue. Just a second. So now we have like we have our data structure, right? So if someone were to add these details, example, let me see. So if we want to put a list, right? Let's say we will have 1,000 residents, and obviously we will need a list of all these residents and where they live, right? So that's the next step. We will need a list of all residents. So to do that now, we are going to introduce a concept called an array. Yes. So an array is just, it's like holding related data. So when you normally when you like program and then you see square brackets, that means it's an array. Okay, so this is how, because we want a list of all these residents who are staying here, and so we're going to use an array to hold all these 1,000 people there, right? So to do so, we're going to come here and pick the name of this person. So let me just quickly remove this because we don't need it. So we are now going to do like a person. Oh, sorry. We're going to call the sort of array. We want it to hold this data, right? So that's why we're going to initialize like an empty array of a person, because a person is holding all the data, right? Yes. So once we do that, now there's something else which I'm going to introduce, which is called visibility in Solidity, right? So I'm going to make it public. I'm going to talk about this in a bit, and then I'm going to say like this is list of residents. So why have I made this array public? It's because, let's say you're writing a smart contract and you need whatever functionalities you're writing it to be accessible outside of the smart contract. What do I mean? You want to make this, whether it is a function, whether it is like something we call a state variable, which we haven't gone through yet, and whether we have essentially just this is actually like a state variable. Okay, what do I mean by a state variable? I've written it outside of okay, no, let me not use that. So the reason why I'm calling this a state variable, it's because, let's just quickly go through that. Variables in Solidity. So there are two types of variables, right? We have local variables, which we're going to see just right now, and then we have something we call state variables. So state variables, this now comes into another concept of which you can always go read it through because of time, of something we call memory in EVM. So what do I mean by state variables versus local variables? A state variable, this one is stored permanently on the blockchain. So this array here, we want it to be stored permanently on the blockchain, right? So if someone new is being added or if someone is being removed, there will always be changes to the blockchain. But the list of all the people who we want to be on the blockchain, we want it to be permanently stored in the blockchain, right? So that's why, if you can see, I have not put it inside of any function, of which, if I was to do so, let's say I wanted to like if I was to like I don't know, maybe no, the right function maybe, or function something, right? And then we make it public. So if I wanted to, like, let's say put the array inside here, this would now become like, okay, you're not even supposed to do so, yes. This will now become like a local variable. So the difference between these two, remember, this one we're going to, like I said, we're going to store it on the blockchain. So it will go into a concept of, when you check the memory in EVM, it will go into something we call storage. Okay. So we're storing something on blockchain, right? So if you don't want to store, let's say you're just creating like a temporary function, a temporary variable, it will always be coming inside of a function. So this is what we now call a local variable. So this local variable, it's kind of like how if you're writing a program, let's say, or if you're doing something in your computer, we have the permanent storage, right, which is in SSD or HDD, and then we have the RAM, which sort of like a temporary memory, where if you're running something, you're going to get memory from the RAM, and then once you're done with whatever you're doing, the program you're running, it's sort of wiped away from the RAM, right? So it's the same thing here. So if you want like temporary variables, which will be working inside the scope, and by scope I just mean inside this curly braces, if you want just temporary variables, you're going to put them inside functions, right? And we call them local variables. But something which you want it to be persistently stored in the blockchain, you're just going to put it outside of any function or anything. So it's going to be directly accessing the contract, as you can see. Okay, so as you can see, our person public list of our array, it's just outside in the contract, right? It's not confined to any functions. Okay, so this is what we call a state variable. That's why, if you saw the error which I was having earlier on, when you're working with like state variables, you need to sort of put the visibility, which one you want. By visibility, I mean you can make it either public, you can make it to be private, or you can make it to be internal. What have I forgotten? Public, private, internal. I feel like I've forgotten another one, but I'll remember it, right? So you can by public.
External.
External, right? Yes, external. So when you check this, we call them visibility identifiers, if I'm not wrong, right? So
There
public.
is a question. There is a question.
Mhm.
Based on the public and yeah, there is also
Okay.
virtue. So the question is, what is the determinant for choosing between implementing a variable to be local or state variable? I think you you can answer that one, and then there is also virtue.
Okay, so like I was saying, when you are using like a state variable, it's when you want the sort of data which you want to pass it through, you want it to be stored persistently across the blockchain. Okay, to give you more context of how these things work, let's continue and then you can be able to see them live, how state variables versus local variables work, right? Otherwise, what I'll be talking about, it will be very abstract. So I think it would be nice if we see it if we see it practically. Okay, yeah. So like I was saying, we have this. I'm going to get back to you. Okay, so we want to see how local variables versus state variables work. Okay, so we have listed all the residents, right? So we have a list, right? Yes. So now we are here. If we add a resident, we want a log of the change in state. So what that means is, if we add someone, we sort of want to receive like some sort of, we want like a logging history. Example, on this and this date, at this and this day, Jordan was added to the residency register. On 25th of this Cindy was added to the register. You're going to see how it comes, right? So here we use something we call events. So an event is just to capture all the important changes of state which you want, and you want them to come as logging so that to help even in debugging and all these things. So if you're changing some sort of state in the blockchain, or you're changing something, example, when we come back to our smart contract, if we add a new person, we don't want to just add and then there's like no notification. Let's just call it a notification in brackets, right? We don't want to add someone and we don't have like a notification. Okay, so how do we get like notifications in brackets in I mean in the blockchain? We use something we call events. Okay, so we are going to write it and we're going to say event add a person added person added, right? And then we're going to give more details of whatever we are adding. Okay, so what are we adding? We'll come back and we'll use this to help us. Okay, so we are adding like a string name, and then we are adding a what, a uint 256 age, and then the residency status, right? So if someone is added to our register, we'll sort of receive a notification of which you're going to see it when we deploy and start interacting with our smart contract, right? So this is the whole point of events. So when you see this event keyword, when you're even reading smart contracts, you just know, okay, this one is sort of bringing a notification of whatever was changing the state of the blockchain. Okay, so I mean, we can just use it simply, or in a high level way, we say this one is just to record all, or to like give you notifications of what is happening when it is like called, right? Okay, so with that, now we are now going to the last thing which we're going to do is, gosh, I hope I haven't muted myself. Okay, yeah. Okay, let's continue. Now remember, I had my list, right? This one. So example, if I added someone right now, let's say it would look like Cindy, 23, and lives here, right? And then Jordan, 24. Okay, let me put let me just put this, right? Just for you to see how it would look like, right? Moved away. And then we have who? Jackson, 28. Lives here. Okay, so this is how essentially when we start inputting our data, which you're going to see when we like start interacting with the smart contract, this is how essentially it would look like at a higher level, right? So what if I want to get the details of Jordan? I don't really, let's say you're working with like a registry of 1,000 people, right? I want to like get the details of Jordan because I don't know the details of Jordan. I've forgotten, right? So how do I implement this in a way that if I input the name Jordan, I get all his names? Because this will be a very important feature in our smart contract, right? What if after everyone whom we have gone down to Nairobi and then we've collected the details and then we've been adding them to our registry, how do we find a way to get the details if we input someone's name, right? So we are going to come that next. So to do that, essentially, you use something we call mapping. So just a quick recap from where we started, right? So we have related data. We use the struct, right, to get the related data of the people who we are using, right? And then for their status, if they live here, if they moved away, like the way we said, you can use either a boolean, or if you want to use like an enum, you can use an enum, right? And we connected the enum to our field here in the struct person, right? Residency status. Now we made a list of all these residents and we called it list of residents, and then we made it public so that it can be viewed outside of the contract, right? So if you wanted it to be private or even internal, you could just put internal over this. And by the way, if you forget to like write the sort of visibility you want for the feature you're working on, by default it's going to go to internal. Okay, so when we start interacting with the smart contracts, I'm going to show you now these nitty-gritties and you see how they affect your smart contract. Okay, so let's just quickly finish up. So we've had our array, right? This is like now the list of all the people who we have in our registry, right? And then now we have emitted an event to receive notifications in brackets. So if someone is added, a new person is added, we sort of receive notification that someone new is added. Okay, now we are here, we're currently working out the feature of if I want to go and look up someone's details in our register, how do I do so? So we said you introduce a concept we call mapping. So with mapping, it depends with what you want. What do I mean? In our case, I said I want to input the name of a person and then I get their entire details. So the name is here, right? The entire details of a person is in a struct, right? So to do this, I will have to map, and the way mapping works, it works in a form of key value. What do I mean by key? Example, if you go to a library, by the way, and then you have a code, because most of the books, they have some sort of a code, right? So you go to the librarian and you're like, I want the book 07, whatever, that one, right? So using the key value, you're going to use this as the key, and then you're going to use it as a key, and then now the value will be the book, right? Let's say the Art of War or something, right? So this is how key value works. So you have a key and then it is mapped to the value. So if you're looking for something, you have to present the key and then to get the details. And on this end, our key is who? Our key is the name, because we said our key, we want it to be Jordan, right? And then the value will be Jordan's details held in person struct. So I hope you're getting a vision of how we are like going to write this. Okay. So with that, we are going to say Jordan. The type of a Jordan is string, because we're not going to like write Jordan here because his value, like his details are not hard coded in the system, right? So here we are going to say our representation of a name is what? String, right? So we are going to say string, and then you use this equal to. It's like to sort of to say not equal to, but to sort of connect to what you're doing, right? So okay, sorry. Yeah, so we want our string, which will be Jordan, right? And we want the details, which will be his name, age, and residency status, which are held in the person struct. Okay, so to get all these details, we are going to include the person here, like that. So we are going to have like string mapping to a person, right? And then with that, we're going to make, let me just remove, or rather, let me just, okay. Yeah. So with that, we're going to make this mapping what? Public, so that it's accessible. Okay. And then we're going to give it a name. So we're going to say let's look for a good word. Name to resident details, like that. So with that, we've mapped our registry here in this tract, right? So if you want to look up, let's say Jordan's details, because we've mapped here, of which you're going to I'm going to show you how you add details. If you map it here like that, you now have the name to resident details. Okay, so we've now mapped our data to the name. So if you're looking for someone who is in the registry, it's going to give details. And most importantly, if you look up someone who is not in our register, it's going to output 0, which is like default. It's kind of like how the default of a Boolean is true. Is it true or false? I think it's false or true. I've forgotten. Or yeah, the default of a uint 256 is 0. Okay. So if you look up someone who is not in the registry, it's going to output 0. Okay. So with that, I think we're all set. I think we can now start writing the functions which are going to execute. Okay. So the first thing is we want to write a function of someone adding their details. Okay, so we have mapped out our data structures, we have mapped out everything that we want. So right now we start writing our functions, right? So the first function is we want to add someone to registry. Okay, so to do that, we are we're going to put the function, and then we are going to like we're going to give it a name, add new person. Okay, so this is like a function like that, right? So inside this function, we want to put more details about this function, this person who we're going to like add, right? So we're coming here, and if we're adding a someone, what details are we adding? Essentially, we're going to add like a name, age, and residency status, right? So we're going to input inside these brackets over here and something we call parameters. So we're just giving more details of which information should be passed to this function. Okay, so with that, we're going to do something. Our name is like a string, right? And then we're going to do something very important, which I'm going to talk about in a few. So we're going to call a keyword called memory, and then the reason why I'm using this underscore here, it's sort of like creating a temporary variable. I don't want to put this name like this because at some point you're going to become a bit confused. Okay, so it's like a writing standard so that you can be able to differentiate what is what. Okay, because this is just a temporary placeholder for our names. Okay, so we have string memory name. Why do I have memory here? Because remember, I said a string is like a complex data structure. Okay, so this complex, it's like when you go and check a string in the backend, like I said, it's like an array of bytes. So it's a complex data structure in itself. Okay, so everywhere you put a string, you have to specify the location where it is. Why am I saying so? If I put like a string name like that, and then, okay, just a second. So, okay. So if I put a string like that, and then let's just continue, and then we say you int 256 age, and then like that. When we finish, you're going to see why it's going to like bring. Okay, let me just remove all this. Okay, let's see what type of error is going to bring. Okay. Syntax error, no visibility specified. Did you intend to add public? Yes, that's because I haven't added the word public here. So if you see, like, let's go back to that error. Okay, so if you see the error here, no visibility specified, that's because when you're dealing with like state variables or you're dealing with functions, you need to put the sort of visibility which we're talking about. It should be either private, public, internal, external, like that. Okay, that's why it's throwing this error, no visibility specified. Did you intend to add public? So obviously I'm going to add public. Okay, so now let's come here and see the error. Type error, data location must be memory or call data for parameter in function, but none was given. This comes back to now when we're dealing with things like strings, we're going to have two types of things, right? We're going to have memory or call data. Um, Memory, like I said, remember a string is a complex data. So we sort of have to specify the location where it's going to be stored. Okay, that's why we're putting either memory or call data. Now the difference between these two is memory, when you're calling memory, this means you're sort of reading from it and you're going to write, or rather you're going to, what's the terminology, you're going to sort of change, you're going to make it mutable, and I'm using the word mutable. You're going to sort of change this string. Okay, but if you use the call data, in fact, with the call data, it's like you cannot append anything, you cannot change anything. Okay, it's like immutable in nature. So that's one of the many differences between memory and call data. I'm going to give you more resources on how this plays out, especially on the under the hood, with even how the EVM handles memory, so that it's easier to like digest this. Okay, but in the meantime, I think we're going to continue. And if I've lost you, please just say, so that I'm not like speaking to myself, essentially. Let me just have a quick water break and then.
As you have your water break, there is some questions. So what the external guys, don't worry, I'm in the dark. As you.
What?
I'm saying I'm also in the dark, but don't worry.
Oh, electricity has.
So what's the external and internal mean? There is also a question on, I did like to know why we are passing arguments within the brackets of the function. So those are parameters which Cindy is passing. Those are parameters, and then the logic is passed within the. Could you go back to the remits IDE? The arguments which are being passed, those are parameters, and they are the ones which hold local variables, which are temporality. And then where you have the public, there is curly braces. There is curly braces. After the word public, Cindy. After the word public, that's where now you add your logic. That's where you add your logic to the code. Yeah. Now, external and internal means that the function can be used externally by other contracts. or other contracts. And then internal means that the function is only used within the contract itself. So it cannot be exported. Like you cannot import it to another contract. Yeah. So that is
Yeah,
yeah, that is what it
yeah,
means.
yeah. To add more information to what Jordan is saying, when you see like a function is external, remember sometimes you're not going to write like a smart contract to be standalone. Okay, wait, have I? Yeah, you're not going to like write a smart contract to be standalone. Sometimes you're going to write smart contracts which interact with each other. Okay, sorry, let's say I have this smart contract for the local directory. Someone has like a smart contract which has another local directory where they we sort of, okay, like a global directory, if I can say so, right? Let's say someone is writing a smart contract to have like a register of all the people in Kenya, right? So we have these local people, let's say in based on the areas, right? So Nairobi area, we have this smart contract which is capturing our data. When it comes to central region, we have another smart contract which is capturing data. When it comes to western, there's another smart contract which is capturing data. And now we have another main, like the mother, if we can call it like the mother smart contract, and these are the child smart contracts, right? So now our mother smart contract wants all this data for that all the regions to be coagulated, right? So in that manner, we will need to design a smart contract in a way this external smart contract, like our mother smart contract, is able to access some of these functions, like some of this list of residents. That's why we've made it to be public. Like it will be able to do what? It will be able to get this array which has our the residents, right? So it enables interconnectivity between smart contracts. So if it's the same as external, right? So if you make your function external, you're just saying, I want this other smart contracts to be able to interact with my smart contract. I want the mother smart contract, which has a local directory for everyone, to be able to interact with all these other smart contracts for the regions and obtain data from which they have been able to collect. So that's why you put like products external. If you put internal, that means that these smart contracts will not be able to they not be able to sort of interact with this smart contract. Yeah. So that's the difference between external and internal. Okay, let's just take a quick break. Let me just go through the questions and confirm so that we don't overstimulate you guys. Okay. Yeah, so far where we are currently, have I lost anyone before we continue? Yeah, just a quick thumbs up before we continue. Okay. Remember, I'll after this session, because I mean it's not, we cannot be like, it's, if you don't understand everything, you can always have time to go through and redigest this again. Okay. And then also in our Telegram channel, we're going to like we're going to what's it called? We're going to like give out more details, and yeah, so that you're able to like what's it called? You're able to redigest this information again, okay, to avoid feeling overwhelmed, that is. Yeah, so let's just continue. Yeah, I have seen a question, by the way. So memory and call data are passed only to arrays, structs, and mappings. So memory and call data are normally passed to strings, because like I said, with a string, because it's a complex data structure, you sort of need to give out the data location, like the precise location where this string is being held. So when you put memory and normally call data, you normally use it with strings. Yeah. Okay, a bit lost, but I'll find my way. Don't worry. In case you, I think the best thing would be all the questions that you have, you can always sort of pull them out. And then after here, we'll be having like office hours. So in case you have any other questions you have not been able to understand, we can go through it again and we can be able to help you understand generally. Okay. Yeah. So after this session, we're going to hold like office hours, and then yeah, to help you out, even if it's the assignment or if there's something you haven't understood. And also you can hit my DM on Telegram, and if I don't see your message, please just tag me also in the Telegram group, and then I'm available to help you out, and also the team is available to help you out in case you're lost. Yeah. So don't worry, we're going to hold your hand as much as we can. Okay. Okay. So let's continue. So where were we? Yes, so we are adding someone new to the registry. Okay. So with that, remember, if you're adding a new person, we need to push the details into our list. Okay. So to do that, we're going to call this list of residents array, this one. Okay. This one. So we're going to call list of residents our array, and then we're going to use a method which is called a push. As you can see, I've already been given a push here. So when you're dealing with arrays, you're given like a set of methods which you use to either input details in the array, which is push, or if you want to remove details from the array, it is called pop. Actually, these are similar to most programming languages. So when you're dealing with arrays and you need methods which are either to add new details to the array or to remove it, you do what? You use push to add details to the array and pop to remove. So they are actually similar to most programming languages. Okay, so we do that dot push, and then now remember we are going to add this entire struct. Okay, so what I'm going to do is I'm going to call it here, and then I'm going to, in the order in which we like put our details, I'm going to example of the first name is name. But remember, I'm not going to put name here. I'm going to use this parameter which we put in our function. Okay, so what that means is if someone is, example, if another new person, let's say Michael, if he was adding a new name, it's going to be temporarily held in this local variable we call a name, right? So now this name here, because remember this name that we have here, the one that does not have an underscore, it's sort of just a general it's just general like field in our struct, right? So to be able to access the specific details which are being added at the moment, you're going to input these parameters which we passed here inside the function. Okay, so we're going to do name, and then we're going to do age, and then we're going to do residency, yeah, status, like that. So this is for adding details to the struct. Okay, I mean adding details to the array. Okay, so with that, let's actually compile our smart contract and then we try and deploy it to see how it looks like for now. Okay, so we come here, like I said, remember this is a simulated environment. Okay, so you're going to do what? Okay, so deploy. Okay, so let me just remove this. So we now have, I don't know if you guys can see, our smart contract is now actually deployed, okay, in the simulated environment. So what do you see here? Remember, I have my function here, add new person, right? I have a list of residents, which is our array. Where is it? List of residents here, which is here. And then I have the mapping, which we mapped here, name to resident details, right? Although we haven't added anything to the mapping. If you've seen, we haven't added, so it's just like empty for now, okay? So if you come here, how do we normally interact with our smart contract? By the way, before we even go there, let me show you guys something. So let me open up the terminal and then you see how essentially it looks like, right? So when you check the terminal, actually, let me redo that again. Let me sort of redeploy again. So, and remember, when I'm hitting on the dustbin here for deleting, it does not mean that we've deleted. If you were like deploying it on a on a test net or on the mainnet, it does not mean that you've deleted it on the blockchain. It just means you're removing it from this remix interface. Okay. Yeah, so don't think that. Remember, it's immutable. Once you deploy it, there's like no removing it. Okay. So when we hit on deployed contracts again, you can see something very interesting, which is happening here. Yeah, let me just check this one. Virtual machine. This is like when we've deployed. Okay. Oh. Okay. So I'm trying to like it's not working. Okay, hope you guys can see. So
you can try and zoom out a little bit.
Okay.
There.
Okay, you can see well, right? All right. So we have the status of our like smart contract transaction mined. Remember, everything that you're doing, including smart contracts, when you're deploying it on the smart contract, on the blockchain, it's the form of a transaction. That's why we said everything it's like under the umbrella term of transaction. So the blockchain sees it as a transaction. Okay. So it's not just currency, which is like in the form of transactions in the blockchain. Also, when you're like deploying a smart contract to blockchain, also when you're interacting with it, which you're going to see, right? So now this is the transaction hash. If we had deployed it on the test net, when you go and check something we call block explorers, example for Ethereum is Etherscan, right? If we had deployed this on, let's say, a test net, if you come here, we could using this transaction hash, we could have like put it. Oh, what's happening? Yeah, we could have input it here, and then you see your smart contracts, you see your smart contract details and all these other things. So that's the work of a transaction hash. Okay, so block hash, this is the specific block which has the details for your smart contract. Okay, and the block number which has been mined is 36, and then this is now your contract address. Okay, even if you come and see here, it's the same as this one 0xec. So this is the address which is assigned to your contract when you deploy it. Okay, now from this is the account which has sent the gas fee for deploying this smart contract. Essentially what I mean is this one, and you can see we've already paid gas fee. And what do I mean by gas fee? Because this one, when it started, it was 100 ether. Now it is 99.99999 ether, right? What do we mean by gas fees? So gas fees was introduced in Ethereum because in Bitcoin normally we have like block space. What do I mean by block space? Each block has a specific limit of the transactions which is supposed to stay in one block before you transmit to another block, right? So we have this block space in Bitcoin. It's like 1 MB per block, 1 megabyte per block, right? So in now Ethereum, there's no concept of block space. It's now gas fees. So if it's like you're paying for executing this smart contract, and everything else which you want to be added to the blockchain, you're paying for the execution, like power, which has been used by the nodes, which will be like confirming your smart contract, and also any steps that or anything you want it to be stored in the blockchain in itself. Example, we've paid for storing this list here, this state variable. We've paid gas fees to store it in blockchain, right? So Ethereum did not limit people in terms of block size. So there's no like a limit. So if your smart contract is beyond 1 megabyte, it poses like a problem or something. But the more things you're storing in the blockchain, the more expensive your gas fee is going to be, right? So sometimes you're told to try and store as little as possible on the blockchain, because you'll be paying for it a lot of gas fees. Okay, and also when you're changing the state of the blockchain all the time, you're still going to pay gas fees for every execution. So this is the model that Ethereum used. So essentially, it's like you're given unlimited, in quotes, unlimited storage, unlimited CPU, unlimited RAM, but you're paying for whatever you're using for in gas fees. Why did they put that? Because imagine if I run a loop, like if I'm looping through something and I haven't put like a stop to it. If I run that smart contract, it's going to just be looping through and through and through and through without ever stopping. It's like infinite. Okay. So when you continue like that, you'll find out like eventually you're using up a lot of CPU. So that's why they put the concept of gas fees, so that the more you're using this material or the resources in the blockchain in Ethereum, the more fees you're paying. Yeah, that's why we're paying gas fees, right? So yes, so this is what I wanted you to see. So this is now like now the data, this is the input which we have. Now the output, like as you can see, it's in the form of like bytecode. Okay, so this is now like the machine code which the machine understands. Okay, yeah, so this is like now the output. Okay, now here are the decoded output. Here we could have seen which we're going to see when we continue. We could have seen like a human readable version of what the bytecode looks like. And remember, when you inputting an event which we haven't emitted yet, it's going to come up here as logs. So back to this. Yeah, so that's what I wanted you guys to see. Back to this, you can see here I have like an orange button saying input required, right? Add new person. This one, add new person. What is it? Add function, add new person, right? So if I do like Cindy, age 32, and then something which you need to realize is when you're dealing with enums, you sort of list them in sort of integers. You don't, yani their index wherever they are. So I'm not going to put leaves here because it's going to throw an error. If I do so, if you come and check here, it's going to throw an error. Add new person error encoding arguments, error invalid big number string, argument equals to value, value equals to leave here, code equals to invalid argument. So if you want to say like a resident lives here, you put the index, and indexes in computer science they normally start with 0 instead of 1, right? So essentially, if I want to say Cindy lives here, I put 0 like that, and then we add a new person. And the reason why it's orange, it's because it's a new transaction. Okay. Yeah. So when you check this, transaction mined, transaction exited, see, we've already paid gas fees. And remember, because we're changing the state or we are adding new people to the blockchain, we are going to pay for a lot of gas fees, because this is 106,394. That's a lot of gas fee, right? And that's just gas fees, and then we have the transaction cost and the execution cost. Okay, so when you check here, after adding a new person, this is like the output. It's going to be very like the in the beginning when you deployed, right? So when you check the decoded input, this is now like human readable format of whatever we've added to the blockchain, or to our whatever details we've added to the blockchain, right? So like you see, I've added Cindy 32 and residency status 0, meaning lives here, right? So if I want a list of residents, I'm going to do a 0, because remember, everything starts as an index 0, right? So string name is Cindy, user interface is my age is 32, and residency status, I do what? I live here, right? So the reason why these buttons are blue is they're just reading, like just retrieving information from the blockchain. They're not making any changes, right? That's why they're blue in color. So that's why if you're making a function which will change the state of the blockchain in Remix, you're going to see it in like an orange button. Okay. So Yeah, so I'll just because of time, we may not be able to finish up on all the functionalities I wanted here. So let's just finish up on something, and then I'll share the entire list of the smart contract, and or rather the entire implementation of the smart contract. I will add in all the comments, and then in case you have any other questions, we can always talk further in like Telegram. Okay, so okay, let me just quickly get this back. So let's just finish this one for adding a new person. Okay. So the first thing we did was we pushed the array to we pushed details to the array, right? So the next thing that I want to do is I want to map the details we've added. We are adding to the array to get to the key value pairs, right? And to do that, since we had already created like a mapping, we're just going to call it, okay? So we're going to say like name to resident details, and what will be our key? Our key will be the name, right? This name over here, which we are adding, okay? So we're just going to say, sorry, what have I done? Name, like that. And it's going to translate to the details in all the persons of struct, in the struct person, right? So it's going to come back like this, and then it's going to have like the name, the age, and the residency status. And to see what we were talking about, events, notifications when adding a new person, we're going to like now implement the event which we had added, right? So we're going to say emit, because with an event, you emit an event, right? So you emit person added, and then you write the details which have been added, which is the name, the age, and like that. So let's recompile this. Okay, when you see a tick here, it's compiling well, right? And then we come back to our deployment, and then we sort of redeploy again. Okay, so
Yeah.
just to see,
Cindy,
yeah, yes,
as the contract deploys, something to note is that every time you deploy a contract, you are deploying a new instance of a contract. Like you're deploying a
yes,
new contract. If you make any change to the functions, if you try to go back to the contract you deployed earlier, it would have the changes. Yeah. So also contracts are immutable.
yes, yes, like he said. So every time we're redeploying again, it's like we're deploying a new instance of the contract. So it's not it's not like we're rewriting the older one. It's like we're deploying a new contract. Okay, so let me just come back here, and let me just delete that, right? So that we're not confused, and then we redeploy again. Okay, so as you can see also, even the address has changed. It was not the previous address that we had, the contract address. Okay, it's like a new contract address. Okay, so when you come here, let me just, okay, so let's go back and we add a new person. Okay, so let's say Jordan, 25, he lives here, so we're going to put 0, right? We add a new person, and then let's add another person. So Cindy, 24, and let's say I moved away, so I'm going to put 1, right? We add a new person. Let's put a third person, so we're going to say like Michael, 30, and he lives here, so we're going to put 0, right? We add a new person. So when you check the list, first of all, something which I want you to see in terms of events, right? If you see, you can see now we have logs, right? If you check all these transactions, even this one previously, we now have the concept of logs. That's why we use events, okay? Because you can see now here at the logs, it's like saying from our contract address, and this is the topic, and then our event person added, right? And then the arguments are Cindy, 24, and residency status is 1. So 0, 1, 2 just means like the index of like the details which you are adding, right? So the name will be at index 0, the age will be at index 1, and the residency status will be at index 2. So as you can see, this will be the row logs. So that's why we use events. So in case something you want to, in case you've changed the state of the blockchain and you want to emit an event so that you can have logs, you always use events, right? That's why we have the event person added. So per every person we've added, example, the last person we added was Michael, right? You can see the logs here. They capture the details. So they sort of give like a notification of the details which have been added to the blockchain. So that is the work of events, right? In the blockchain space. Yes. And something which you note here, the coded input, it's like a human readable version of the data which you've just added to the blockchain. Yeah, it's something we call like an ABI decoder. So this is something you can go and check. So we have like an ABI application binary interface encoder, and then an ABI decoder. Okay, so this is just to help give human readable information about the details which you've input to the blockchain. Okay, so Remix actually helps you interact with your smart contract a lot, as you can see. So you can now continue adding more details, right? So that is the function add new person, right? So if we want to get like a list of residents at integer, at index 0, I'll just come here, and then this was the first person we added, right? So these are his details. So remember, when you're getting like the entire list, especially in an array, you use indexes. Okay, so this is at index 0. If I want to get details from index 1, I will come here and then I'll get the details which I want, right? If I come at index 2, I'll get the details here. But why do we need mapping? Because remember, let's say you have 1,000 entries, right? And you want to look for someone's detail, but you don't know the exact index where they are, right? That's why we put the concept of mapping. Because if I come here and I just look for Jordan, there we go, I get his details. That's why we mapped the name, which was a string, into the entire details of the person, which was the struct. Okay, so if you want to map something to like another thing, and to help you when you're like looking out for if you're looking up, let's say, your data which you're storing in the blockchain, you use mapping. Okay, because it helps a lot. Because if I come here again and I check Michael, I have this data. If I come here and I check Cindy, I have this data, right? So what if I put like the number 24? Let's see what sort of error it's going to like transmit here. Yes, it's actually it's not an error per se. It's like it's outputting 0 because it does not know who 24 is. Okay, because at this point, because the input is a string, the 24 will be like.
Yes, sorry, Cindy. I wanted to add something on the array. The reason why we are getting like the string. So we have like two types of array. We have like a fixed and a dynamic one.
Yes.
Yeah, so this one is a dynamic one. That's why we are still getting a data. So there was also a question on what determines like what types of data, like how do you define the data? So I think from when Cindy started, she started with defining. If you can go up to the comments, the beginning of the comments, she started defining what type of data we do need. Like she defined the names are related data, which means now we need abstract. She also defined enums. We need to know where someone lives to. Uh, we need to know whether they are still there and such. And she also defined the list of people who are residing in different residency and such, and how you can be able to like log those changes. So you have to like define the data that you do need in your contract even before you start building a smart contract. You define the data that you need, and then that will determine how your data structure will look like in your smart contract. Yeah.
Yeah, thank you. So that's the reason why I'm assuming you are not maybe you were absent at the start of the call. So at the start of the call, we actually did start with code. We started by going through the entire problem which we're trying to like solve, which is we're trying to create like a local a directory of people living in a certain area, right? So we started by putting down the details which we need. We sort of made like a model, like a mental map of everything that we need, right? So in here where we got this data, it's because we knew if we want to like we extrapolated, if you want to like get the details of someone living in, let's say, Nairobi in Kenya, what sort of data do you want from them? You want their name, you want their age, and you want to know whether they still live in Nairobi or not. Yeah, so that's where we actually got this data. So we didn't sort of guess it. It was because when we started the call, before we even wrote our smart contract, we sort of wrote down everything that we need. And we sort of made all the things and all the data, yeah, all the designs that we need, the design implementation that we need for a smart contract. Yes, that's why. And also something Jordan has mentioned, which I forgot to mention, is in an array you have dynamic and static arrays. Okay, so the meaning of dynamic is this array can grow in size or shrink at any time. There's no limit. So the number of people who we're going to add in this list of ours through the array, it can grow or shrink indefinitely, right? So what if we want to like sort of restrict it to a certain number? So that will be static, right? So you will put, say, let's say 5 or 7, and like put 5 here, right? So if you put it like that, that means that we're sort of restraining the number of slots, if I can call them slots, in our list to capture maybe at most 5. So that one will now become a static array because it's expected to hold only 5 objects inside of the array. But if you want it to be like indefinite, because you don't know the number of people you're going to add in your what, in your list, you now put it like a blank. Okay, so it becomes dynamic. It's just like how, example, let's say year, and then a year has how many months? 12, right? Ugh. So this would now work if let's say we had a struct for a year, right? And we wanted to capture only 12 slots because we know we have only 12 months in a year, right? So we're going to make it static. So it's just only going to hold 12 slots because we know the amount of data we are dealing with. So this is now what we're going to call a static array. But when you're dealing with data which you don't know, like the amount of data you're going to put into, you make it blank here and then it becomes dynamic. Yeah, so that's the difference between the two. Okay, so what were we doing? Yes, so we were talking about that. So because of time, because our session is actually almost up, and I don't want to like overload you guys with a lot of things. So there's some things we have not added, which I'm going to like give out the finished smart contract having all these lists. Example of the functions we have not added is function which checks the residency status of a person in the register, right? That's one. And then another function to count the function to count the number of residents living in the area. So this one is we're counting the people who essentially lives here. Yeah. So what I'm going to do essentially is I'm going to in our Telegram channel, I'm going to release like I'm going to give out the smart contract having these features, and then I'll put a lot of comments around it. And if you haven't if it's still not understandable, I think over the weekend I can sort of record myself again going through this, and then having added the new functions, and then I'm going to share like the recording so that I can properly explain the two functions which we have not catered for here. Yeah, because of the interest of time, because we have like around 5 minutes and I don't want to rush through the two functions because there's a lot of specifications. But just to give out like a summary of what we've learned today is, I know it's a lot, so don't be a bit overwhelmed. So in case you haven't understood, I'll reiterate again. You can still take time. We're going to share a lot of resources also, which help reinforce what you've learned today, because we've learned a lot of concepts today. And then also just take time to also read through again. I didn't expect to understand everything in just like 2 hours, so it's okay. And also we'll have like office hours, and we're currently available also in Telegram, right, in case you have any questions. Yeah, so but the reason why I took this approach is I wanted you to see live how, if you're given a project, let's say someone comes, or you yourself, you want to like build a smart contract from scratch, the best thing, or to make it very easy for you, is don't just start coding. It's always best to have sort of like a mental map of all the features, all the things you're going to do, and the design related issues or the choices which you're going to use, right? That's how we knew if we are working with structured data, we're going to use a struct, which is like structured data, right? If you're working with varieties, like variants, you either choose this or this. You work with enum. And also, if you want notifications, you work with like event. And by notifications, I don't mean notifications in a literal aspect. I mean in the logs, right? And all these other things. Yes. Yeah, if you want someone to get like to be able to query the database which you have and then get details, you use mapping. And then these are now the functions which you have, right? Yeah. So, okay. Yeah, what is the Telegram link? Let me just
You can drop the Telegram link and also the dedicated Telegram for the bootcamp.
Yeah, I'll just share the dedicated Telegram group. Let me just look for the link right now.
Yeah. So as Cindy shares the link, I gotta give out some shout outs to some of our team members who will be joining us later. So we have Ronet, we have Bressins, we have Soriu, we have Guardian, we have Nahim, we have Hadija. So if you're in any of the 5 ecosystems you're in, that is Celo, Kenya, Uganda, Nigeria, South Africa, and Ghana. In Ghana we have Ebenezer. I think Ebenezer is Pablo. Yeah. Yeah. So anywhere you like, if you look on your left or your right, you're gonna find someone who's gonna be there for you in some of those ecosystem. Yeah. So yeah. I think we had some exciting game here. Yeah, we had
Yeah,
some exciting game here.
yeah, to sort of relieve the mood from being too serious. So we have some sort of game. It actually has prizes, guys. So yeah, to just relax a bit as we almost finish the session. I'm still looking for that Telegram channel. So
Yeah. Uh yeah, so there is also, like, I know some of you guys. I also want to give out some mentions to some of the guys who've been with them in Web3. There is, I can see Rachel, I can see Michael. I don't know Michael. Michael is not from Web3, but I can see he's been joining. I think I can also see Chris, Florence. Yeah, Florence. Then there is also Kat. Yeah, nice to see you in this session. It seems today like I'm in Nigeria. The only
I
thing
think
which is
I
not
thank
there
God.
is the generator.
Yeah, I thank God actually today. I was so worried because we've been having also a lot of power issues. So yeah, at least I was the
G-
stronghold today.
GM Myth, GM. Today I'm in Nigeria.
Hey. Okay, gotcha. Okay, as we wait for Jordan to kickstart the so there's the Telegram. So Jordan, we're waiting for you to kickstart the game, the quick game.
Oh, sorry. Let me.
Yeah, just share the link and then people join in and then we sort of give up. In the meantime, in case there's any pressing questions, I think I can go through it. I really hope I haven't like overwhelmed you guys with a lot of information. So yes, but don't worry, learning takes a bit of time also because also on my end I'm like learning. So yeah, I just hope I haven't like given you guys a lot of overwhelming information, yeah, for today's session. And I hope I wasn't talking too what's it called, too quickly or using a lot of jargon. So I just hope so. And if I was, that would be very nice. Where back? I don't understand that question. Could you maybe repeat it, Akwesi? Hopefully I've mentioned your name properly. Where back? Like, what does that mean? Yeah, just you can just repeat the question. Jordan, what's happening?
Guys, I
What's
think we
happening?
might do this another time.
And you're
Uh,
the one who was the
we might do
principal
this another time.
entertainer.
We might do this
Look at
another
you.
time. Uh,
Okay, so can you share
I'm
the two
seeing I
last
need to
questions?
upgrade to something. Yeah.
Okay, it's okay. I think we're going when we start the next session next week we're going to start with like what's it called? Like the trivia,
Yeah,
and also and also have several prizes in throughout the sessions. Like if you submit your assignments early, and if you're helping out with questions in a Telegram group, yeah. Yeah, he's a very jovial man. Okay, so me, can you share the two last functions you wrote as comments? Yes, so I'm going to share the two last functions. So after the session, I'm going to like give out the entire code piece. So in the Telegram group, I've shared the Telegram channel. So if you're not in the dedicated channel, it will be super hard getting like information. So please join the Telegram channel. I've sent the link. So I'm going to share it immediately after so that I don't forget. So I'm going to rewrite like the last two functions and then share it, and then you can go play around with them. Yes.
let's see if people can join, but I don't know how many people will be able to like join. That is the game ID. So
Okay, let me add to stage. Okay, so the game pin is so just go to this site. Can you share the site link? Let me just look for it. Kahoot.
it's www.kahoots. Yeah, so I don't know how many people will be able to like join because I'm using less, but
The three.
next time we will have a better yeah.
Yeah, don't worry, guys. We're using free things. So just go to Kahoot, and then you put the game pin for 82 789. Next time we're going to have like a proper experience, like a game experience. Okay. Yes. So there we go. So we're waiting for players. So if you're able to just join in, remember the top three guys after this are going to get some prizes. So
Yeah. But I think the game we will only be able to like support. Let's see the guys who joins, and then we see how many of.
yeah. Oh my God,
And, and,
Jordan,
and you
and
guys
may
have
your
to
laptop
do
not.
like. Today is not a good day.
Today's not a
May
good
Lord help
day.
us.
Yeah. Yeah. So we're waiting for
Mungu
people to join in.
I think we can only do like
Nice.
three.
Nice.
We can only
Only
do like
three.
three. Yeah.
Are you kidding
Apparently,
me?
I
Let's
got
see.
it's
Okay.
only three. Yeah.
So if we're doing it with three guys, then that means the three guys will have to fight for just one position, right?
Yeah, just one guy. We need just one
Okay.
guy.
So let's see who's going to win.
So I'm waiting. There are only three people, and the answers are not coming in. Only one person. Let's go to the next one.
So the issue with this is we at least we know the person who's leading. And it's clear. You are given an opportunity. Don't fail the gods. Okay, so
let's go to the next one.
what isn't a blockchain feature? Security,
Oh,
anonymity. Oh my gosh. So I'm thinking Jordan's laptop has gone off because he doesn't have there's a power outage in his area. So too bad. We're going to have a rerun of the same game next week. So hopefully we'll have upgraded the limit so that more people can join in. But otherwise, thank you guys for listening in. Thank you guys for coming into week 2's session. As usual, after you can like write a tweet having the details which you've learned today, and then you can tag us. I'm going to put like in the Celo Africa, I mean in the Celo Bootcamp dedicated Telegram channel, I'm going to put the handles of like Celo, Celo Devs, Celo Africa DAO, so that we can see this. And yes, so after this session, immediately before I forget, I'm going to send the entire smart contract, which how it was supposed to look like, so that you can play around with it in Remix, you can break it, and all these other things. And yeah, during the weekend, I'm going to send like the second assignment. Yes, the second assignment, so which you're going to be working on it. And yes, in case you have any questions, please just ask in the Telegram group, or you can even DM. But in case I miss your texts, because Telegram is quite hectic, so just tag me in the Telegram group, right? And I'll talk to you. And if in case I'm not available, we have like the entire team, so it's not just the two of us. It's only that the two of us are like the face of the bootcamp, but we have like we have an entire team. So yeah, so you're ready for the quiz. Okay, so sorry, we have had a lot of technical challenges actually. If you're in Kenya, at least you probably understand, because of the rains we are having like so many power outages. So yeah, I'm actually lucky on my end. We didn't have like power outage tonight. So otherwise we would have had to cancel and like reschedule the session, right? So just bear with us, Africans. We're going to have better electricity. We hope so, right? Okay, so thank you guys for joining in. See you. Is there anything I haven't said? Not really. So we meet next week, same time, same place. And I'm going to share again. I'm going to share the smart contract when it's like full, right now, before I forget, to the dedicated Telegram group. And yeah, thank you guys for Africa and power outages. It's so crazy because we're having so many issues with power. Like if power goes out tonight, like right now, I'll just go sleep, because the next time it will come is tomorrow in like the afternoon or something. So it's really hectic, especially in the rainy season. Yeah, so some of the issues we're facing in Africa. Okay, so aside from that, we still continue to build, we still continue to code, just continue learning Solidity. This is not like everything we've covered. It's a very extensive language also, so it will take a bit more time. But otherwise, let me release you guys. Thank you so much for bearing through with the 2 hours, and I hope you've understood, even if it's just something out of the entire session. And yeah, good night, guys. You have a lovely night. And I hope to see you same time, same place next week. And please do the assignments. And in case of anything, just let the team know. Yeah. So with that, I'm going to end the live stream and see you guys next time, next week. Yes, next week, same time, same place. Week 3, where we're going to now talk on a deeper aspect of smart contracts. And we're also going to we're also going to talk more about front end. Okay, Ruto must go. Yeah, Ruto must go, obviously. Okay, so see you guys. Bye bye. Love you guys. Bye. I'm going to end the stream. Okay. Okay.